Most computation program nowadays is going to be able to find eigenvalues and eigenvectors of a matrix for you. For example, if I want to find eigenstuff from these two matrices from the earlier example, this is from example 9.2 and this is from example 9.1. Then I can just actually go ahead and ask Python to do it for me. To input the matrix, I'm just gonna input them as np array, so that's gonna be np.array, and then I'm gonna have my bracket. The first row is gonna be 3, 8, and then the second row is gonna be 0 and -1, 0 and -1. Now to find the eigenvalues and eigenvectors, the command for that is gonna be np, that's for numpy, and then lin out. This is linear algebra .eig. So this is eigenvalues and eigenvector all together. So I want to find the eigenstuff for this matrix A. Now this command is gonna output both the eigenvalues and the eigenvector. So it will output two things. So I'm gonna have value be my eigenvalue and then vector be my eigenvector. And then I'm gonna ask it to print out the eigenvalue that I have and also the eigenvector that I will get. Okay, let's see. So here is the output. The first thing that we see, this is the eigenvalue. So we have seen from the earlier example that the eigenvalue of this matrix is gonna be 3 and -1, and the eigenvector that corresponds to the eigenvalue 3 is gonna be the first column that we see here, which is 1, 0. But now the eigenvector that corresponds to the eigenvalue -1 is gonna be this weird number. But we know that the eigenvector is gonna be a span. And if we look at the earlier example, we kind of see that when my eigenvalue is 1, the eigenvector is gonna be the span of -2 and 1. And if we look closely at the number that we have, the top number is just -2 times the bottom number. So in fact, this is one of the eigenvector that we have found from the example. But because of the way Python do things, sometimes we get kind of funny number like this. So let's actually try to have Wolfram Alpha compute the eigen thing for me. Okay, I'm just gonna go ahead and input this matrix without asking anything. So Wolfram is actually gonna be smart enough to actually compute all the stuff for me. So Wolfram gave me the inverse, the characteristic polynomial, and here are the eigenvalues and eigenvectors. My first eigenvalue is 3 and the eigenvector is going to be 1 and 0. And the second eigenvalue is -1 and the eigenvector is going to be -2 and 1. So let's try another example that we have. So another matrix that we have is going to be 2, -2, 2, -2, and then -1 and 3, -1 and 3. Okay, let's see what we have. So this is the same numbers that we see from earlier as well. The first eigenvalue is 4, and the eigenvector is going to be -1 and 1. Another eigenvalue is 1, and then the eigenvector here is 2 and 1. Now let's try the matrix from part C then. So my matrix is going to be 0.9, and then 0.3, and then 0.1, and then 0.7. Okay, let's see what we get. So now we have two eigenvalues. The first one is just 1, and the eigenvector is 3, 1. Another one is 3, 5, and the eigenvector is -1 and 1. And the last one is going to be a 3 by 3 matrix. So let me go ahead and change this. This is going to be 0.94, the next one is going to be 0.03, and the last one is 0. For the second row, I'm going to have 0.04, and then 0.98, and then the last entry is going to be 0. And I also need to add another row, and the entry is going to be 0, 0.01. Wait a minute. And then the last one should be 0.98. So let's see what we're going to get. Yeah, here comes the eigenvalues and the eigenvectors of my matrix. One of my eigenvalue is going to be 1, and the corresponding eigenvector is going to be 1, 2, 1. I also have 2 more eigenvalues, and here are the 2 eigenvectors. And well, for now, there's no need for us to write out everything, but let me just say that for part C, one of the eigenvalues that I have found is 1, and the corresponding eigenvector is going to be 3, 1. And for part D, one of the eigenvalues that I have found is also 1, and the eigenvector that I have found is going to be 1, 2, 1.